Aloha students, hope you are doing well today and welcome to, what section is this? This is Similarity, Right Triangles and Trigonometry, Similar Figures. So I watched the section and I thought the instruction was pretty good in it. Are going to need that distance formula at times out there, they mentioned that. There are a couple alternatives here that we need to look at that are possible. Instead of using the distance formula, sometimes you're going to see Pythagorean triples come up. Basically, you're seeing a triangle, a segment, and you're putting a triangle around it, a right triangle, to see it. Special right triangles, I mentioned, so that's Pythagorean triples, special right triangles, or vertical or horizontal lines. Vertical or horizontal lines you can count out. Special right triangles, your 45, 45, 90, 30, 60, 90. It's possible to recognize the number patterns in those and go directly to answers and kind of skip over it. It's still using the same concepts, but you're taking advantage of some patterns. I don't recall them mentioning dilations are centered at the origin. That's why I got the question mark. But yes, they are centered at the origin. The last section in the instruction gets off of that. D for dilation, QN. Q is your center of dilation. Again, that's usually the origin. N is your scale factor. Now, we do have a couple of relationships down here to take a look at. I got this circled right here with this. First off, if n is greater than 1, that means it's an enlargement. If n is between 0 and 1, it means it's a reduction. Number sense will help you there. Here's that Q is the center of dilation, N is the scale factor. That again is relating to this over here. Now, in the formulas, you'll see it's the image equals the scale factor. I'm looking right here. Image equals the scale factor times the pre-image. Okay? My cursor used to work on this a little bit better as a highlighter. Wish I could figure that out again. But and that's related to this down here. When you want to find your scale factor, it's always image over pre-image. But notice what happens. If I multiply, if I multiply by the pre-image, go away. I multiply by the pre-image. They cancel out, and you're left with this right here. Image, you've got image equals n times the pre-image. So those are definitely related. You know one, you can deduct the other using some of your algebra rules in there. Just cleaning that up a little bit right now. Okay. Slide 6 in the instruction. That's what this means, slide 6 in the instruction. There's a couple of squares kind of overlap, and they're looking at finding the distance, and they show this there. This is a case where I saw 45, 45, 90. So they're showing you this little segment right here. Okay, they're finding the distance of that. Well, I put this on right here. That's 4 and 4. That's a 45, 45, 90 triangle. I recognize that right away, and I can snap straight to that 4 root 2 for the length of the side of that rectangle without having to go through our distance formula. That's if you recognize it, though. You got to recognize stuff like that. Not everybody's going to recognize it. Some of you are going to do it the long way and then recognize afterwards you had an opportunity to do that. Okay, we don't need those blue lines there either. Slide number 8, number sense again. I had some other number sense up here somewhere. Where was it? Where was it? Right here. Use number sense. If n is greater than 1, you know the small number has to equal n times the large. This equation would actually make no sense. Okay? If I have a smaller number, I'm not going to take something bigger than 1 and multiply to get that. Just use your number sense. In this case, it'd be the large number equals n times the small number for n greater than 1. Think about those things. That's where people make common mistakes. Not using their number sense. Number sense again, remember, if n is greater than 1, that means it's an enlargement. The pre-image should be smaller than the image. Thus, the reciprocal is why you multiply on that. If n is between 0 and 1, the pre-image is going to be larger than the image. They're talking about working backwards on these. That's why we end up using the reciprocal, because we're going from, in this case, a smaller to the larger. So I got to pause this because I didn't. Slide 8, this will make a little bit more sense when you view the slide. They're talking about going from the image to the pre-image. Earlier, you're going from the pre-image to the image. Since you're going from the image to the pre-image, that's why you have to end up using the reciprocal. You're going backwards. Can't multiply by a number. You got to undo it. So that's multiply by the reciprocal. That's the same as division. Slide 11, definition of similar figures. Don't forget the angles. Corresponding angles need to be congruent. For proportional, that's going to be the corresponding sides. That's where a lot of our math work comes in. We have this little property over here some of you like for similar figures. We don't really use that in here. It's more of a drawing one. You can see it in some of the diagrams. For instance, I don't know why that came up. This diagram right here. You can see those lines going towards the center. In there, the gray and the orange one. But also what I wanted to note on here is this point right here, A, B, C, the small triangle. Pay attention to the points. A is also like B prime in this big triangle. But since it already had the name A, they just left it at that. Don't expect everything to change to A prime, B prime, C prime. Here, B prime is actually the same as A. It can serve two parts. Serving two masters. Number 13, a little more detail oriented on those problems. You may want some graph paper for this. This is when our origin is not at the center of dilation. That's when that's coming up. So that's really it. I wanted to go quicker on this, maybe next time. Thanks much. Y'all have a good day.